Okay, for this example, we have a 500 ml steel reaction vessel, and carbon monoxide and water vapor are reacting to produce carbon dioxide and hydrogen. So the first step is to write a balanced equation for this. So we have carbon monoxide plus H2O gas reacts to produce carbon dioxide and hydrogen. H2 gas. Okay, and the next step would be to balance, and everything in this case is balanced, so my coefficients are all going to be a 1. Now we want to use this to write an equilibrium law expression. Remember, expression means we're showing a relationship between variables. There's no numerical values that we're subbing in. We're not solving for an answer. Kc equals products over reactants. So we have CO2 to the power of 1 times H2 to the power of 1 divided by CO to the power of 1 times H2O. Because water is a vapor in this case, we're going to include it in the equilibrium law expression. Liquid water and solids are never included. Determine the initial concentration of the reactants. It tells us that 2 moles are placed in a 500 milliliter steel container, and we always have to substitute in moles per liter when we're using the equilibrium expression. So my first step is to convert that to moles per liter. So 2 moles divided by 0.500 liters gives me 4 moles per liter. Then we want to set this up into an ice table. So I have 4 moles of each of my reactants. It doesn't indicate anywhere in the question that we have product initially in the container, so we can assume that these are 0. Now the difference between this question and ones that we've seen before is this time we're not given a value for any of them at equilibrium. So normally if we have I and we have E for at least 1, we can use that to solve for the others, but in this case we don't. So if there's no product to begin with, then we know the reaction has to go in the forward direction. So these are going to decrease by some amount, and my products are going to increase by some amount. But we don't know what that amount is. So if I say that carbon monoxide is going to decrease by X moles per liter, because these are a 1-to-1 ratio, then the H2O will also decrease by X moles per liter. We can use the mole ratio then to figure out what these are going to increase by, my products. And again, they're both at a 1-to-1 ratio. So we're going to have plus X moles per liter. So then in this case, at equilibrium, I would have 4 minus whatever the change is. Okay, and these I would have 0 plus X, so we'll have X mole per liter. Now I can use the equilibrium law expression to solve for X. If we go back to the question, it tells us what the K value is, so I need to know the K value to be able to solve for X. And we're going to sub those numbers into our equilibrium expression that we just set up. So it's products over reactants. And my products are both X to the power of 1. So X times X divided by, the reactants are both 4 minus X. So we have 4 minus X times 4 minus X. My K value is 4.20. And we can simplify this expression because X minus X is the same thing as X squared. 4 minus X times 4 minus X can be written as 4 minus X squared. So to simplify this, we can get rid of those exponents. And to cancel out a squared exponent, we take the square root. We have to do the same thing to both sides. So square root of 4.2 is 2.05, and this is equal to X over 4 minus X. So we have to solve for x. We can start by getting rid of this fraction. So we'll multiply both sides by 4 minus x to cancel here. And when we have two terms inside of the brackets, we have to multiply the 2.05 by both of those terms. So 2.05 times 2.05, sorry, times 4 is 8.2 minus 2.5 times x is 2.05x. And this is equal to x. Now we're trying to solve for x, so we have to start by collecting all of the like terms, all of the x's. So I want to move this to the other side by adding 2.05x. You can imagine that there's a 1 in front of the x. So we're adding 1 plus 2.05. So that gives me 3.05x. Last step is to divide both sides by 3.05 to cancel this here, and we get x equals 2.69. Okay, we're not finished yet though, because this is the value of x. It's not a value of the concentrations. It just tells me what my unknown is. Now we have to go back and sub this in, given the x value that we now know. So initially we had 4, and we know that the change is 2.69. So this gives me 1.31. Here we had 4 minus 2.69, 1.31. And these both started at 0. So we add 2.69 to give us our final concentrations at equilibrium. So this is what we're solving for in the question. So if this were, an exam or a multiple choice, it might just choose one of the items and ask you to solve for what the equilibrium concentration is. So you have to go back once you know x and sub it into your ICE table.